So now I'm going to show you something called vertex form of a quadratic function. So there are different ways that we can write the equation for a quadratic function, okay? And so we learned all about how to graph a quadratic equation using standard form, right? Ax squared plus bx plus c, okay? Now we're going to look at something called vertex form, and it just means that we're still going to be dealing with a quadratic equation. We're just going to write it a little bit differently. But the really nice part is when we write our quadratic equation in vertex form, we can automatically find the vertex instantly without really having to do any work at all. And we can also use it to find the axis of symmetry. So let's take a look at that. Okay, so let's take a look at this vertex form. So what we've been doing when we've been graphing functions, right, is we've been looking at y equals ax squared plus bx plus c. We've been looking at standard form, okay, and we know how to find all kinds of things using standard form. We know the concavity, we know how to find the x-intercepts, we know how to find the y-intercept, we know how to find the vertex, we know how to find the line of symmetry, right? We've learned all about that. So what we're going to do now is we're going to just take a step away from standard form, and we're going to look at something called vertex form. And the really nice part about using vertex form is right in the name. If you use vertex form, you are basically given the vertex in the equation, okay? Because as it turns out, when we graph parabolas defined by this form right here, f of x equals x minus h squared plus k, well, the parabola is still going to have the same shape as y equals x squared, so as a normal parabola. But the vertex is going to be given to us. So whatever number is here and here, that's going to be our vertex, okay? So we're literally given the vertex in the equation. And then the axis of symmetry, we know that's the vertical line running through our vertex. Okay, well, if h is the x-coordinate of our vertex, then the axis of symmetry has to be the line x equals h. And so it makes it really useful for us to graph our quadratic functions, our parabolas, right away, because you're being given the vertex in this vertex form. So let's put some context to it. So let's say I asked you to find the vertex and the axis of symmetry for the graph of y equals x minus 3 squared plus 1. Okay, I immediately know this is a quadratic function, a quadratic equation, because the degree is 2, right? We know any equation of degree 2 has to be quadratic. Okay, it looks a little different than standard form, right? But we're not going to get scared. We're going to just say, oh, wait a second, this is that other form. This is that vertex form, right? When I have this quantity of x minus some number squared plus something else, that's that vertex form Mrs. Stugard told me about. So I'm going to actually be really excited because when I'm in vertex form, I'm given the vertex right in the equation, okay? So I know that my vertex is the max or min of my parabola, and I know that the axis of symmetry is the vertical line that goes through the vertex, and I can find those really easily. The vertex, we know, is hk, okay? H is just the number that's coming after the subtraction sign, and k, right, k is just the number that's being added at the end. So all I need to do is look at the function that I'm given here. Here's my h, and of course, here's my k right here. So I know the vertex immediately. The vertex here is 3, 1, right? My h was 3, my k was 1. And now, since I know my vertex, I know my axis of symmetry because that's the line that goes through the x-coordinate of my vertex. Well, my vertex here was 3, 1, which means the x-coordinate of my vertex is 3. So the axis of symmetry for this parabola has to be the line x equals 3. So whatever h is, whatever number is here, that's your line of axis of symmetry as well. So if I were to graph this, right, I could plug in a few numbers for x, and I could do my whole xy, get some points for this parabola, right? I could do my whole xy chart, plug in some values of x. I know my vertex, I know 1 point, but I need at least 2 points to make a graph, right? So I could do that, plug in, but I'm just going to give you the graph, okay? This is what the graph of x minus 3 squared plus 1 looks like. And I know my vertex is 3, 1. There it is. It's a minimum. And I know that my axis of symmetry is that line running through my vertex, the line of x equals 3. So, don't get too thrown off by this form, this vertex form. It's actually really handy because it gives you the vertex and the axis of symmetry right in the formula, right? It's giving you your vertex, boom, boom, and your axis of symmetry is the line that runs through the x coordinate of your vertex. So you're basically given all that information just in the form, which is very nice, okay? So you are going to be seeing that on your homework. You will see it on your test. You might even see it on your final. So definitely be aware of it. Let me know if you have any questions.